Hello and welcome to TN Academy. For today's question, we have a set of probability questions, okay? Where, for a question, we're given a bag that contains n balls, okay? We are given a bag that contains n balls, and it's known that 10 of these balls are green. So, n balls, where 10 are green. The rest of the balls, X for the time being, are red. And it said that, balls are drawn from the bag one after another without replacement. That is a crucial point because that involves combinations rather than permutations. So for A, we're asked, find in terms of n the probability that, first off, question I, that the first ball drawn is green. So for this probability question, we're asked to find the probability that the first ball drawn is green. Green. Then in terms of n, we know that there are 10 green balls and n total balls. So that is our probability in terms of n. And I'm going to rewrite this as pi is equal to 10 over n, just to save room. Now for our second question, we're asked to find the probability that the first two balls drawn are green. So I've written the situation choosing the first two balls as green balls out of our, n is equal to 25. Okay, well, our probability, the first two balls are green. Okay, yeah. So the probability of this is we have the product of two sets of probabilities where we multiply first the probability of selecting 2 green balls out of our 10 green balls, so 2 out of the 10, and then we have the probability of choosing the probability of the number of different ways to choose 2 balls out of n balls. So the probability should be written as such. It also is the same as saying, okay? So moving on, for our next question, we're asked to show the probability that the first 2 balls are red is 0.35, where we let n equal 25, okay? So for this question, if n is equal to 25, then the probability that the first 2 balls are red is the number of ways to choose 2 balls out of 15 divided by the number of ways to choose 2 balls out of 25, just like the question we just did essentially. And the reason being that the number of red balls, if n is equal to 25, because that's the total number of balls, should be n minus 10, since there are 10 green balls. 25 minus 10, which is 15, okay? Just to clarify that point. So that when we write out the probability P of scenario B, we get the probability of selecting 2 balls out of 15, and then the probability of selecting 2 balls, again, out of multiplied by probability of selecting 2 balls of 25. Okay. So this would, give us 105. divided by 300. Okay, so this here we have, so yes, just to clarify again, this is the probability of selecting two red balls out of the 15 that we have divided by the number of different ways to choose two balls out of 25. We divide the two probabilities and then we get 105 over 300, which is also equal to 0.35. And the same goes for the equation above. It's the probability of selecting two balls out of the 10 green balls divided by the number of different ways, the probability or the number of different ways to select two balls out of the n total number of balls. Okay, so now for question C, we are asked to find the probability that the first three balls are all red. So to do this, so the probability that the first three balls will all be red would be the number of ways, the combination of selecting three balls out of the 15 red balls divided by the combination of selecting three balls out of 25 balls, the number of different ways that balls could be picked from both the red, the number of red ones, 15. So P of C is say number ways three of red divided by number of ways to select three out of the total. Okay? So then we get the first combination divided by the second combination, and that's what gives us our probability, where we have 25 total balls and 15 red balls. Okay, so that after we compute that, just a moment. So after computing that, we get 455 over 2300, which is equal to 0.1978, and I've rounded it to be approximately 0.198. Okay. Now, for our next question, we're asked to find the probability that at least one of the first three balls is green. At least one. Okay. So to answer this, the probability that at least one of the first three balls is green will be 1 minus the probability that none of the balls are green. Okay, so 1 minus the probability that no balls are green in the first three. So we write this as 1 minus the probability of selecting 0 green balls from the first, from 15, it's actually supposed to be 10, because we have 10 green balls and 0 of them are selected, and it's divided by our 25 totals balls and the different ways of selecting 3 from our 25 total different balls. And then when we compute this, we get 1 minus 1 over 2300, which is about 0.996. When I've rounded, yeah. So the probability is about 99%. Okay. So then for our next and final question, we're given quite a bit more information. We're asked, we're saying a game is played where 4 balls are drawn, one after another, from the bag of 25 balls without replacement again. A player earns points based on when the first green ball is drawn. At the end of each game, the 4 balls are put back into the bag. A player earns 0 points if no green balls are drawn, or if the first green ball is picked on the first or second draw. Okay. A player earns 10 points if the first green ball is picked on the third draw, and earns 50 points if the ball is picked on the fourth draw. Now, Millie plays this game K times She finds her score by adding together her points from each game, of course. Now, for question E, we're asked to find the least value of K such that Millie's expected score is greater than 100. Okay? So we can say, with all the information gathered, write out the necessary given variables, but the expected score for one game is 0 points. If someone 0 points multiplied by the probability that no green balls are picked, plus 0 points times the probability that a green ball is picked on the first or second draw, plus 10 points times the probability that the green ball is drawn on the third draw, plus 50 points times the probability of the green ball being drawn on the fourth draw. And the expected score for K games will be K times the expected score for one game. So we need to find the least value of K so that the expected score is greater than or equal to 100. Greater than or equal to, is that right? Yes. They ask, find the least value of K such that expected score, so it's actually just greater than 100. Okay? So when we substitute all of our values into this equation, we will get an equality. So if we continue on, we can see that the scenarios where we will get 0 points, as the probabilities are being multiplied by 0, we can just strike them out. And what we will focus on is these cases where we get 10 points and 50 points respectively, where we have 10 points multiplied by the probability of selecting one green ball out of 10 and divided by the probability of selecting one ball out of the 22 remaining balls, since 3 balls, it's actually incorrect, the 2 remaining balls, since we will be on our third draw. And so 22 balls will have already been removed. And for the second case, we have 50 multiplied by the probability of selecting one green ball out of the 10 green balls, divided by the probability of selecting, or the number of different ways of selecting one ball out of the 25 less the 3 balls that have already been selected. So then we should get 10 multiplied by 10 divided by 23. So there would be 23 balls. In this case, we'll have 22 balls, since 3 will already have been drawn, okay? Okay, so then when we continue on to solve for the equality, again, we get 10 times 10 over 23 plus 50 times 10 over 22, K greater than 100. And when we evaluate this further, we get 10 times 10, of course, 100 over 23 plus 500 over 22, all times K. And we can simplify this expression inside of the brackets so that we get 27.04, K greater than 100. And then when we isolate for K, we get K must be greater than 100 over 27.04, which is approximately 3.698. And that is our value for that question. And that's all for this question today.